After that, what is he doing? He has a list of vowels and he has a list of numbers. Okay. So, okay, the code is that way. Fine. So they have created a list of numbers and a list of vowels, and then they have written a filter. So filter means a function, remember? So first parameter to the filter is always a function, which can be written as a separate function which takes x as a parameter, or it can be written as a lambda function right there. So this person has written a lambda function, which is fine. So lambda x, it should give me true if x in L1, else false. So that is the first list. This will be the list of vowels. So what is that doing? It is checking for a presence of an element in that list, and if it is there in that list, it means it's a vowel. So all the elements which are not vowels will be filtered out, and it will produce a list. So whatever is getting produced is converted into a list by saying list output of filter. So remember, a string is also a list in a way. So L4 is equal to list filter, the second condition where we are going to pick up the numbers in the string. Lambda x true if x in L2. So those are the numbers. Else false. And P is the given string. As I said, the string can be treated as a list of characters or numbers, whatever. Every string is a list of values each. So that is what you have to keep in mind. So this was the answer to the third question. Okay. For those of you who have not done it, this is the hint. And then there was a fourth question, which is digit sum of an element using reduce. Okay, so you have to take each digit. So if you take if you are given an input, take that input as a string, go through each of the elements of the string, convert it into integer and add it. Okay. I think that is how most of you have done it. That is how this has been done. So look at this. We are using reduce from func tools. We talked about that. Then we have L is equal to input, enter list elements. And whatever is entered is split. So L is a list of whatever values that you have. So in that case, in the upper example, L will be a list of strings 121, string 2364, string 15 and string 84. So that will be the string in original. Then that has been converted into a list. I think L itself will give you a list. So line 12 may not be needed. Okay, but S is equal to reduce. Now reduce always needs a lambda function as a first parameter and whatever the list on which it has to work as a second parameter. So lambda, because it's a reduce, takes two parameters, x and y, and they are added in their integer. So that int is being used to convert from character to integer, because int of x plus int of y will convert x and y into integers. So, okay, for those of you who are a little slow, I'm just showing you what will happen. So, so we will do here, so here, after this line, I'll have a list. This is not needed as I said. L will be a list. List of what? 121 as a string, 2364 as a string, 15 as a string, and 84 as a string. Remember? Square. So I'll have a list of strings here, L or L1. So this is a list of strings. Each is a string. So what is happening is, now for I in L1, this is the list comprehension, very nicely written. For I in L1, so first time I will be the string 121. Okay. What is he doing? He's taking 121 and converting into a list. Even that may not be necessary, because a string is automatically a list. If you had, I think, written just I also, probably it would have worked. Okay, but doesn't matter if you make sure that what you are getting is a list. So this list of I, when you do a list of I, it will become 1, 2, 1 as characters. Each will be a character. 1, 2, 1. This list of I will be 1, 2, 1. Each is a character, or each can be a each will be a character. Then what we are doing? Then we are saying, as we go through this, we are converting 1 and 2 into integers. See this, int x, int y, both are converted into integers. So they will become 1 plus 2, which will become 3. And then this is 3. So that becomes the x for the next one. So this is 3. And then 3, integer version of 3 is 3. Plus 1. 1 gets converted into integer. It becomes 4. So 1 to 1 will become 4. Okay. And similarly, 2, 3, 6, 4 will become 2 plus 3 plus 6 plus 4 by the same total. Okay. So this is how this code will work. Okay. Then, so S will be the reduction which you have to carry out, and answer will be this. So good. So whoever did this is good, and this is what we want you to do. Okay. So today we'll move to the next data structure. I think we have been doing lists for 2-3 sessions. Now we'll move to the next data structure which we want to discuss, which is which is as comprehensive, which is called the dictionary, or it's called a map. In other languages, we call it a map. In C++ we call it a map. In Java we call it a map. In Python we call it a dictionary. In C#, that is .NET, we also call it a dictionary. So this vocabulary is different, but they mean the same. So what is a dictionary? Dictionary is a combination of key-value pairs. There's a key, there's a value. And just like list uses a square bracket, dictionary uses a flower bracket. Now dictionaries are going to be very common for us because when we are going to program, when we are going, probably not in this semester, next semester, when we are going to talk a lot about full stack and web programming and all that, we are going to use a language called JavaScript. And in that language called JavaScript, we are going to deal a lot with both lists as well as what are called JSON objects, which are dictionaries. So in today's world, whenever we program on the internet, that is, we create a web application or a website, we deal with what are called JSON objects, JavaScript object notation, which are nothing but glorified dictionaries. Okay. So dictionary is a super important data structure for us. Written in the same way like we are writing in Python, we will have more to do with it. So we must master the dictionary, and let's see where we get. So as usual, for no better reason, I'll use W3 schools. Just walk through what are some of the dictionary functions, highlight some of those which you need to understand, and then we can proceed. Then we'll do some exercises to just understand how dictionaries work. And then we will soon give you exercises which combine lists and dictionaries, so that you get both of these paka. Okay. But today let's address only dictionaries. Maybe there are some lists somewhere. Okay. So let's start and check. So this is a dictionary. As I said, it can be called a map. So a dictionary consists of a bunch of key-value pairs. So the first one is called the key, and the second one is called value. Those of you who are fine, you're just using W3 school, so you can look at your console also, in case you are not able to see. So this is a dictionary. So here keys are brand, model and year, and values are Ford, Mustang and 1964. So anything can be a key, anything can be a value. That means it need not be integer or it need not be string, it can be a combination. Same thing with value. There is no restriction on how it should be. Then dictionary, go on. So yeah, there are some changes there. We'll skip that. So if you print this dictionary, you'll get the dictionary as it is. The same way as it is shown here, same way it will be shown. So let's just run. So when we print it in the program, we'll say brand colon Ford model Mustang. This is string. And here, if you see here, I think here is integer, so it doesn't matter. Okay, values can be anything, value types can be also anything. Okay. So, okay, let's move on. Okay, now what is a dictionary item? Each pair is called a dictionary item. So in this case, I'll say this dictionary has 3 items. Each item consists of key and value. So each, in other languages we call it an entry. Each is called an entry. In Python we call it an item. Are you clear? If you go to C++ or Java, we'll call it an entry. Each key value pair is called an entry. So here there are 3 entries. Yeah, come down. And there is some kind of ordering. Don't worry about the ordering right now. Next. So it is changeable and duplicates are not allowed. Duplicates are not allowed on the key. Value we don't care. So the key cannot be duplicated. If you put another key which is existing and put another value, that second time what we do, that value will override. Just like an update operation. We'll see some of that. So we go to so in this case we have brand Ford model Mustang year 1964 and again year 2020. So obviously if we print it, we'll get year as 2020. The earlier value will be washed out. Okay, we can check that. So if you see there, so year is 2020 as you can see. Okay, next. Then there is a length function available on a, just like you have length on a list, there is length on a dictionary. What does length on a dictionary tell you? How many items or how many entries are there in a dictionary? So in the current dictionary there are 3 entries. Okay, we'll skip that. We'll go forward. Okay, dictionary. Now this is interesting. So for branch, if you see, there is a single value. For electric, also there is a single value which is Boolean. So you know how to write true and false already. And for year, it's an integer. And for colors, see the mix of data type in a dictionary. So for colors, the value of colors itself is a list, no problem. Correct? So some fields may have different kinds of keys, and keys will be similar, I guess. Values can be whatever they want. Sometimes it will be lists, sometimes it will be single values, sometimes it will be integer values, whatever. So I think this is no need to run it. So when you say type on a dictionary, it will say I am a class dictionary. When you say type this dict, it will say I am dictionary. Next. Okay, we move on. Okay, how do you access elements of a list? Of a dictionary. So this is a dictionary. So the easiest way, this is the way you see it in Python. A similar way we'll see in C++ when we talk about maps. You just say square bracket. Okay. So you have a dictionary, square bracket key. You give the key in the square bracket, response will be the value. What we get is the value. So that is pretty easy to access. Just say key and you will get the value. But please don't forget that you have to put a square bracket there. When you are accessing elements of a list using the key, you have to put square bracket, like in a list. But it's not a list, it's a dictionary on which you are doing indexing. It's called doing indexing. So you will say model. When you say model, it will go to the key model and see if there is a key model and print Mustang. Okay, so here you will get Mustang. Now this is one way of doing, or you can also use a get. So this is actually the Java style. The earlier one is the C++ style, so they have both. So you can do a get on the key also. But I generally don't like this style. I prefer the square bracket style. It's easier to write rather than writing a get and then trying to get the value associated with that key. Okay, this is a little irritating. I mean, it depends again on style. It does the same thing. Given a key, gives the value associated with that key. And if it is not there, okay, that is important. So we'll do that and see. Okay, let's give a value. If you run it, you will get that. But let's say just mod. Whatever. Okay, just say mod. So this is important to see what it gets. Okay, it gives you a none. None is a reserved thing in a Python code. So if you want to see it is not there, you will compare it with none, and it has to be written none like that only. Just like T has to be written uppercase in true, F has to be written uppercase in none. We don't use null, remember? Don't get confused with null. There is no null. We don't use null in Python. We say none. N-O-N-E. This is the none. When it is not there, check it is not there. Achha, the same thing you can get if you do a square bracket also. Can you just change that? Run it again. Yeah. I forgot this. Get gives you none, and if you use square bracket, it gives you an error. If the value doesn't exist. So which is safer? Get is safer. If you're not sure that the value doesn't exist, are you with me? Then you should use get. If you're 100% confident that the value exists, then by all means use the square bracket. Correct? No? Square bracket gives you an error if the value is not there, key is not there. Get gives you a none, doesn't give you an error. Okay, we move on. Okay, so yeah. Then you can say keys, plural. So all the keys in the dictionary will be taken and a list will be produced and you will get a list. So if you do keys plural, you will get all the keys of the dictionary in a list. So then you can work with it. Some people use this also to check whether it is there. They produce a list and they say if not in this list or if in this list then do something. They do that also. Checking for what are there. Or if you just are interested in what are the keys, you can do that straight away. Okay, so this dictionary dot keys. Okay. Then we move on. Okay, so when we say car dot keys x will be a list. So if you print that, you will get that. Now, how do you add things to a dictionary? Very simple. You can blindly put the square bracket, give the key and value. So you can just add it, treating it as a key value pair. You don't have to have a separate operation called append or add or something. If it is not there, it will get added. So look at that line. Car color is equal to white. Perfectly fine. So far there is nothing called key color. It is getting added. Okay? Very simple. So this is a good point of using dictionary this way. That you can blindly add it. Okay? For this, in Python, in Java, you have to do a put. This is called a put operation, where you are creating a new entry. So this is like creating a new entry in the dictionary. This is very simple. Just put the square bracket and it is there. If it is there, it will update. If it is not there, it will create. So, for example, if you add one more line, let's go. This will produce, he is printing dictionary keys. So first there were 3, now there is 4. Now you can print the cars also later. So just change year to 1963. Car, year. This is an update operation. Equal to 1963. And print car. Print car. We are printing the entire dictionary. X car. X is only the keys. Okay, so you see there, color and then year. Year has become 1963. It changed from 64. The updating of the dictionary is a very simple operation. You just have to take the key, put different value, update. Okay. So moving on. Just like you have keys method, you have values method. Keys will give you keys, values will give you values. List of values. Values will produce a list which contains all the values. Okay. It's a list. Okay. I don't think here you will get Ford Mustang in 1964 and 2020 if you want. Okay. Instead, Okay. Now there is another method called items. So there is a keys method which only gets keys. Are you with me? Then there is a values method which gets you only a list of values. Now items. Item is one entry. Items is all the entries. How it will give you? It will give you as a list. List of what? List of tuples. You know what is a tuple, right? Though you have not done it formally, we know parenthesis. So you get a list of tuples. If you say items, okay. So let's just see how you get this. So print x. Print x. You see there. We are getting a list. Items is a list. It's printing the data type also. So dictionary items. So dictionary items is just to say it's a dictionary items. But each element is a tuple. Brand 4, that is a tuple. And you see outside there is a list. So you can do it this way. Next. Then change. Okay, what? Make a change to the original dictionary. Okay, that is fine. It's just updating and then it's printing after the updating. Okay, car items before updating and car items after updating. No, this is important. Okay. This I would like you to think. This items method is and I think even keys method, these are a little tricky. Okay, now you have to understand why they are tricky. Okay, please listen to this carefully. Now, at the moment, if you look at this code, car has how many items? 3. Then I am saying x is equal to car dot items. And if I say print x, what will I see in print x? It will be a list of tuples. How many tuples? 3 tuples. Each tuple having a key and its value. 3 tuples. Okay, then after that we are saying car color is equal to red. Now how many items are there? 4. But I am again not saying x is equal to car items. Are you getting? So x is a reference. So items returns a reference, meaning it is not returning the actual value. If it was returning the actual value, the first x would have only 3 tuples. And the second x would have had 4 tuples. But what will happen here is, what will happen? Though x I had created earlier, car dot items is a reference. So it is pointing to that list. So if that list changes, x will still point to that. So when you run this code, some of you may expect the first x to show only 3 tuples and the second x to show 4 tuples. But that is not what happens. The first x shows 3 tuples. Sorry, what you would expect is the second x also to show only 3. I'm sorry. Oh yes. Because you have not again created x. X was created before, then a new pair was added. Okay. So many of you will say, I should get the old x only. But what is going to happen, because items is a reference, it is not getting the data and keeping it. It is just referring to that data. When you say car.items, when you say x again, you automatically get 4. If you wanted earlier one to be preserved, you should have done a copy and then done items. Okay. So let's do that for a moment. So let's try it out and then we will make a change and then try it out. So see here. So first time, that is the first x, you see, what is the data which is produced? We have 3 entries. Okay. The second x, though I didn't say car.items again, got 4. See, the second x got 4. Though I didn't say car.items again. Now, if I had said, okay, let me do this. Y, after x is equal to car dot items, make y is equal to x dot copy. Let's try. Okay, and then we will say print y. No, wait, are we doing it right? X. Then we are printing x and we are printing y. Y should not reflect. That is because we cannot copy it that way. We should copy directly. No, say car dot copy. We cannot copy items. So now, so now this is, actually I should say x, instead of saying items I should say x car dot item. So if you notice what's happening, my y, which is a copy of x, is preserved. That is not changing. X, which is a reference to items, if the dictionary changes after that, automatically x will reflect the change. But y doesn't. Because y is a copy of x, copy of car. So this is something you have to be keeping in mind. Anyway, I think this is adequate. Go next. So we know how to get items. Okay, next. Achha, now you can check whether a particular key exists or not. That is easy. So the key check can be done directly on the dictionary. So if you have a dictionary like that, this dictionary, so many keys. If model in this dictionary means it will check whether model is a key or not. And if it is a key, it will give you the value associated. Okay? Or it will say model is one of the keys. So that is how you check whether key is there in the list in the dictionary or not. If model in this dictionary. So this dictionary will check for keys. Though you didn't say that. The other way you could have said it is, if model in this dict dot keys, because that means you are checking in the list of keys. But that is automatically understood whenever you say if model in whatever is the name of the dictionary. It will check only in the keys, though you don't say dot keys. Okay, so we will move on. Next. Okay, now how do you change? That is update values. We discussed that. That is very trivial. Use a square bracket, give the key, give the value. Okay, very straightforward. So that is how you update a dictionary. So you just say either that way. Okay, no, there are two ways. Yeah, this is one way of doing it. That is just use the square bracket. Or create a new entry and use update to do that. So this is not calling update. Here it's calling update. You can say this dictionary dot update, then use flower bracket for the entry and say this key, this value. So if the key matches, the value will get updated. In this case, the year will get updated to 2020. Next. Okay. We're just going through the add items. This is how the items automatically get added. We discussed this. Or this is the other way to add items. So add items same way. Either you can just say square bracket or say update and give a key and a value pair. Okay, next. Removing items from a dictionary. Pop. Pop if you give with key. Okay. Pop if you give it key, that particular entry will be removed if the key exists. Then there is another thing called pop item, which will make it work in a LIFO way. Last in, first out. Pop item. Just like on a list there is pop. By default, pop without any parameter is a LIFO operation. Here it is called pop-item, which will remove the last entry in the dictionary. The dictionary has entries. So the last entry will go away. If you say just pop item without any character. If you want a particular thing to go, just say pop with the key value. Okay, next. Then delete is similar to pop, the same way, only thing is you say delete this dictionary model instead of pop. Pop, the way it is called is different. We say this dictionary dot pop, just see, go up. So the way you call pop is like a method, delete is like an operator. So delete is like an operator, which is a reserved word. It's not a method. Then this dictionary model. So this is how the key, the entry will go away for model. Okay. And if you say delete this dictionary itself will go away. The whole dictionary is removed. And similarly, you have clear. We saw in a list also there was clear. What will clear do? It will retain the list but make it empty. Same way, if you say clear on a dictionary will be there but it will be empty. Okay, straightforward. Next. That is clear. Next. I think we are. How do you loop through a dictionary? That is, how do you go through a dictionary? If you say like this, for x in this dictionary, it will loop through all the values. So each x will be a tuple of the key and the value, if you say like this. So you can say it has two parts, key and value. You can run this if you want. Oh, there is, yeah. So for x in the dictionary, oh, I'm sorry. When you say for x in this dictionary, it only looks at keys. I'm sorry, it doesn't print the key and value. So for value, you will have to say print this dict of x. If you want the value, or you can write a comma and say this dict. So when you say for x in this dict, as we saw earlier, it checks only the keys. So we can write this way and see what happens. So this will produce what we want, key value pair, or you can do items. Okay. Then, so this is how you get the value. Okay. Now, if you want to loop through values only, you say for x in this dict dot values. We know values will produce a list of values. So if you want to go through that is the way you do. Okay. Keys will be if you want to loop through the keys. If you want to loop through the items, that is key value pair. Now this is important. This is what I was meaning. For x comma y, because remember each item will be a tuple. Tuple, first value is key, second value is value. So you can say for x comma y in this dictionary dot items, x will be set to key, first value, printed, next key, next value. Okay, again straightforward. Okay, how do you copy a dictionary? I think we just saw that. Every dictionary has a copy method. So if you don't want to manipulate that existing dictionary, you want to use some other, just say copy. Okay, next. Okay, or you can just say dictionary, this dictionary, it also creates another dictionary. Okay, next. Okay. I think this is the last one. Then we'll do questions. Nested dictionaries, that is dictionary within a dictionary, where the value itself is a dictionary for some key. For example, let's say you are storing names of people, information about people. So you say name, okay. Then you say age. These are all one field, one value. Now you say address. Address itself is a dictionary. Dictionary of what? Street number, pin code, city. These are all parts of address. So the value of address is not single. The value of address itself is a dictionary, which consists of various parts. So that is a beauty, and it can go nesting to any level. So, and just like a dictionary can have a list, you can have a list of dictionaries also. No? You can have a dictionary of lists, you can have a list of dictionaries, you can have a list of lists, you can have a dictionary of dictionaries, anything is possible. That's how the complexity of the data structure increases. So look at this here. This is my family. So first key is child. Now the value of child, if you notice, is a dictionary, which is itself consisting of name and year. Child 2 has another name and year. Child 3 has another name and year. So there is a dictionary associated with each child, and that each child's dictionary has the name and maybe year of birth or something of that dictionary, of that child. So now how do you use this? Okay, we just say come down. Yeah, how do you access it? So this is one way, but let's see how is it accessed. This is another way of doing it. You create 3 separate dictionaries outside and assign the values. Next. Okay, no, let's do it. So how do you okay, now we'll do one thing. Yeah, I'll say my family dot child 1. No, not dot. Sorry, square bracket. It's not square bracket child 1 square bracket name. Okay, that is Emil. Emil is, I think, the first guy. Okay, so this is how you access nested dictionaries. See there, my family, square bracket child 1, normally is a value, but in this case the value itself is a dictionary. So if you want to access the second field, a field of that dictionary, you have to have one more square bracket with the key of that nested dictionary. That is what we are doing. So you need 2 square brackets. If you have 3 levels of nesting, 4 levels of nesting, obviously you will need to have that many square brackets, one after another. You are going deeper. So this is how you can do. Okay. Now this will be needed very often when you build more complex problems. You will have to design these kind of data structures, which are often a combination of lists, dictionaries and tuples. So you put them together to design for a particular problem, and that takes little care. So you should be easy. It should be easy for you to work with that. Okay, next. Okay, I think we have looked at most of the methods. Those others are not that crucial. So now, what we'll do is do something for you. Very easy question. I hope everybody will be able to do. So we open the first question. Name? What is the name? Name of the question is Dictionary 1. Dictionary 1. Something very trivial. Just to get you started. Yeah, please use an empty dictionary. Empty dictionary is created this way. For those of you, yeah, empty dictionary is created. Suppose you have a dictionary D1. Empty dictionary is this. And you can add anything you want to the dictionary. This is an empty dictionary. Just like a list is created by saying L1 is equal to, this is a list, empty list. This is an empty dictionary. Then you can add, that is by using square bracket, you can keep adding values to it. Okay, now you are going to do this. We don't have a test case for it, so you are going to try it and do it. Maybe meanwhile we can see if we can write a set of test cases. Now, this is a problem where you will need not just a list, you will need a list of dictionaries. You will need a list of dictionaries. List whose each element is a dictionary to store this data. Okay? So, this is what we will need. So now, I have 5. My input is 5. Okay, we'll open a practice question. Okay, so 5. That is the number of people I have, number of employees I have. Now for each employee, I have 4 fields. Name, Sham, age, salary, and designation. Then OPA. Software engineer, deployment engineer. D is deployment engineer. Then like this, there will be 5 people. But you are asked to do a generic question. That means first row of the input, first input will be what? Number of employees. Then if you say n, after that there will be n rows. Each row will consist of what? The name of the person, the age of the person, the salary of the person, and the designation of the person. Designation means what is he? Software engineer, deployment engineer, hardware engineer, manager. So, like this the data will be there. So each employee has to be stored in a dictionary, and the whole thing will become a list of dictionaries. Correct? So you will have to figure out how to do that. It's easy, not too difficult. But this is how you learn. Now, first is you have to take the input of the people, all these people, keep it in a list of dictionaries, and then remember you can append, just like in list, you created a list. Similarly, using append, you can append a dictionary to a list also. Nobody stopped you. Okay. I know we are going a little ahead, but you should be able to do it. Now, what I want is you take all the data, create your data structure. After that, you should tell me the person who is earning the highest, who has the highest salary, and who is a software engineer, SC. Did you get my question? I want the name of the person who gets the highest salary amongst software engineers. Some are software engineers, some are hardware engineers, some are deployment engineers. Like that, there are many different kinds of designations. Only among software engineers, who is getting the highest salary? The name of that person. Are you with me? Let's see how many of you do. Think a little, because this is the kind of problems you have to learn to solve. Not given a list, find out the maximum in a list. So the data will be given like that. Not given all. But the nature of the data is that. You are given at the top the number of people. Then after that, for each people, each person, you are given the name, age, salary, designation. So you have to read all of that, produce a list of dictionaries, and then you have to write a loop which goes through the entire list, goes through each dictionary in that list, and checks whether he is a software engineer, and if his salary is greater than some max salary, updates at that particular point. Yeah, it will require a bit of coding, it will require a bit of thinking, but you should be able to do it. So what we'll do is, we'll pause for, I'll give you 12:30. I'll give you time till 12:45, 12:35, okay, 12:50. I'll give you time till 12:50, 12:50 we will solve. If you're not seeing practice 4, refresh your screen. Just refresh your screen if you're not able to see practice 4. I'm going to start. It's 12:46. Starting a little early, but doesn't matter. Those of you who are doing can continue to do. Others can watch. Remember the input that I have. So first what I do, I'll read the n, isn't it? And convert it into int. So I'll say n is equal to int of input. because input gives me a string. I have to convert that n into a number. So I will say n is equal to int of input. That is the first line. Everybody agrees? Now, depending upon n, I have to create a list of dictionaries. How will I do that? Let's create an empty list first. How do I create an empty list? Let's call it e-list. Okay. E-list is equal to empty square brackets. So e-list is equal to empty. I got an employee list created. Okay. Then what will I do? How many employees are going to be there? N. So I can start a loop which goes up to n. How will I do that? For I in range of n. So it will go from 0 to n minus 1, which is good enough for us. So for I in range n, what should I do? Each time I have to create a dictionary. For each employee, I have to create a dictionary. Add this data of the employee to that dictionary and add that dictionary to list. Okay, so let's say I call it edict. Okay, edict is equal to empty dictionary. How do you create? Flower brackets. Square bracket is empty list. Flower bracket is curly bracket is empty dictionary. I have an empty dictionary. Yes. Now what I have to do? I have to read each line, split it, and assign it accordingly. So when I split it, I'll get it in a list of each string, each employee's data. L0 is the name, L1 is the age, right? L2 is the salary, L3 is the designation, L is square bracket 3. So we will do it accordingly and put it in a dictionary. So what we will do is, we will read each line. So let's say L is equal to input dot split. Now, next line. We'll say edict square bracket. Remember, we are filling up each entry in the dictionary. Edict square bracket. What should be the first one? Name. Do you agree? No. Edict name. Double quotes for name. Name equal to. Wait. What should I say? L of 0. Wait, come on here. Each L consists the data about an employee, no? L of 0 will be name of the person. So, we are saying edict of name is equal to L of 0. Yes. That is a name, so let it be a name, string name. Then, edict of age. Okay, we are doing it 4 times. So, edict of age. Remember the second field is age. Should I say L1 blindly? I should say, good. Int of L1. Because see, L1 by default will be a string. When you split, you will get strings. Yes. So, I will say, I have to say like that. Line 7 please. Edict of age is equal to int of L1. Same way, salary also, let's assume it is an int. If it was float, we would have converted to float, but doesn't matter. We'll say it's an int. So, int of L2. Otherwise, your comparison will not be correct. It will go into ASCII comparison. We don't know what ASCII. Designation is equal to L of 3. Okay, now wait. Did we understand this part? Did all of you understand this part? We are reading N first. We are creating an empty list called E-list. Then we are going for I in range N. We are creating for every employee, we are creating a dictionary. In that dictionary, we are storing data one by one. Edict name is equal to L of 0. Edict of age is equal to int of L of 1, because L of 1 happens to be a number. Int of L of 2, because salary also happens to be a number. And just L of 3, because that is a designation. which is a string. Okay. Now, what should we do after this? E-list dot append e-dictionary. Every employee will be an e-dictionary which will be appended to e-list. So, e-list will become a list of dictionaries. So, I will say e-list dot append. You know how to append things to a list, right? E-list dot append edict. Yes? No? Understood? So, at the end of this for loop, when I come to the next line, after the for loop, what will I have? I have a nice e-list sitting with me, which is a list of dictionaries. Now I can go through each and see whatever I want to see. So, I will create a variable called name is equal to empty. This is the guy who is going to earn the highest salary. And I will create a field called max sal equal to 0. So let's do that. Name is equal to empty. I don't need to do this, but let's do this. Name empty. Right now, name is empty. What am I going to use this name for? Keeping track of the name who is the currently highest. So that's why I need the name. Name is equal to empty at the moment. And max sal is equal to 0. I'm assuming everybody has positive salary. Okay, so max sal is equal to 0. Some notional value. Right? Everybody agrees with this? Yes? No? Now, I'm going to loop through the list looking at each employee. So, for E in E list, I can call it whatever. For each employee E, which is a dictionary, remember? In E list, yeah? Yes? No? You're there? For each E in E list, which is each a dictionary, what do? I check. First of all, if E designation is not SE, I forget about it. So my first check is, because I am not interested in that employee. So if E, square bracket, E is a dictionary, no? Square bracket DS, you are accessing one of the fields in the dictionary. Which field? Des field. If E, DS, designation, equal, what? SE. This should match. If you are given lowercase, you should match lowercase. Otherwise, you should convert it into lower or to upper and do that. I am assuming everything is given in lowercase. Okay. So, if E designation is equal to SE, that is, I am checking whether that person is a software engineer or not. If he is a software engineer, then his salary I will have to compare with max salary. So, if E, what is it, sal, greater than max sal, then what should I do? I should do two things. I should update max sal to this salary. And so far, who is the highest earner? This guy's name. Am I right? So I'll update max sal equal to E sal. E sal. Everybody agrees? I'm updating max sal to E sal because I found somebody higher salary. So max sal has to go up. And also I have to remember the name who is currently the biggest. Who is the software engineer? So I should say name equal to, again that line 11 was not needed, just E name. That's it, I guess. You done? That's all, no? What should we do now? print name, that's it. If you want salary, you can print max salary. But if not, print name. Shall we give it a shot? Yes? Or you want to give it a shot? Either way. So let's just run it. So we'll say 3. The next line we'll say first is name, Ram. Second is age. Third is salary. Fourth is SC. Then Gopal. Sam. Gopal. Salary, age 30. Salary 3,000. D. One more. Sam. 34. 5,000. SC. Okay. So, as expected, we got Sam as the answer. I'll just show you. So, that is the data I entered. Are you following? Not following? I entered the data, 3 number of people, then the people. The people are 2 software engineer, 1 deployment engineer. I'm looking through their data, and it turns out that Sam is the highest salary. You want to just check it once more? You can do it one more time. So 3 again. I don't want to enter more data. Make the second guy the biggest. $2,500. Yes, see, and the rest of it. 25, 5,000. Yes, see. As expected, the answer is coming as Gopal for this question. Okay. Now, are you clear how to do? This is a sample question that we did. It's a list of dictionaries. There are many such questions which we have to do before we get a complete grip of how to work with it. So we can give you this question, right? We can give you this solution. So my suggestion is, we'll give you this solution. Look at it as practice 5. Okay, we'll give it to you as practice 5. Those of you who are interested, who have not typed the solution, you can look at it as practice 5. Play with it a little bit, make changes. It's also available at home. Please use it to explore. The best way to do is make some changes, see how it works, alter it, comment it first, then copy it and print it. Otherwise you lose the original. Refresh your page, just see. It's there? Okay. So it's available as practice 5 for you to try out and do. Okay, we'll do more of these in the next session.